Welcome. This virtual Friday, talking about the blade saw PMs. My name is Tim Elrod. Been with MiTek a little over 3 years. Been working on the blade the whole time. I work in the Amp Force department. If you don't know what the Amp Force department is, we can go over that in a little bit. Jumping right in, if you guys can see my screen. Eric Seeger and I made this presentation last year to help customers with their visual inspections of the blade saw. Each area of the saw is labeled 1, 2, 3, 4, 5. Should be pretty easy to go through. So right now we're going to start back on the back side of the infeed rail behind the saw. This one right here. 1A, open the stroke door chamber and inspect mechanical assemblies, inspect cables and sensors for damage or loose connections. The mechanical assemblies back here are the stroke, elevation, and angle. Right here with this red arrows pointing is the stroke belt. It says inspect the stroke drive belt for damage and proper tension. I like to keep this one at a 1/4 inch deflection up and down. The way I always check it, I go 1 foot off of the pulley and make sure I can move that belt a 1/4 inch up and down. There are 4 linear bearings back here. I don't know if you guys can see my mouse or not, but these get greased once a week. That's in the PM manual. This red tube in the back is the elevation jack screw. That only gets greased once a year. Cables to keep an eye on. Through this whole tube, there's about 4 cables. Yeah, 4 cables that go into the saw head assembly, into the saw chamber. We want to make sure the insulation on those isn't cracking. That's not too tight. There's 2 clamps back here that hold it. Make sure they're not too tight. Just want to make sure everything's clean and not in a bind in any way. This black chain up here with all the other cables in it, you want to make sure that there aren't any cables binding down where they exit out of that chain as well. We have a note down here to blow out or vacuum the chamber to remove any sawdust or debris. I mean, you can check that every day. That's pretty easy. There's even a hole down in the front of this cabinet. I usually just push all the sawdust out through that hole onto the floor and blow it out whenever I'm done. Now we're looking at this is the idle end of the gripper where the infeed rail touches the saw. Open this door here, and if you have an older saw, I think, I don't remember the frame number exactly, but these pulleys that these timing belts connect to, way back when, they were made of aluminum. So if you have an aluminum pulley, I like to inspect that and make sure that the teeth on it aren't worn down. If that pulley wears down smooth, your printer encoder is actually on the other side of this. Your print will be off, and it's kind of tricky to figure out if you don't know what you're looking for. This yellow block right here has got 24-volt wires going to it. I like to verify that this cable on the bottom is plugged in all the way and tight. You can verify the encoder cable on the other side is tight as well. Directly above that door, we have the top clamp assembly. You can remove the plexiglass guard. I like to take off the entire blue guard. It's just 4 or 5 32nd Allen head bolts. The note on the top right, check air cylinder sensors for tightness. You have your clamp unclamp sensor. Just verify that they're not slipping up and down. Check shock absorbers for damage and proper operation. There are 4 shock absorbers on this clamp. The way to check and see if they are bad is push up on the plunger. If it doesn't come back out, it's obviously bad. There are 2 on top, 2 at the very bottom. Check the E-chain and airlines for damage or wear. If you do not have an edge printer, the 7-valve printer on this clamp, you will not have an E-chain. If you do have one, this E-chain is pretty important because it protects all the cables going to your expensive print head. We all know how expensive they are. Check all moving parts of the top clamp, looking for loose or worn parts. At the very bottom of that top clamp, you can see the orange part. We call it the ski. A lot of the hardware loosens up over time because most saws, this clamp is boom, 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 moving way harder than it should. To verify that all that hardware is present and tight. Speaking of the top clamp moving harder than it should, there's a way to dampen that clamp to where it's not slamming up and down, up and down. At the top of this picture, you see this regulator. The sticker says 30 PSI max. I like to keep this one about 10 to 15 PSI. That controls how hard it'll go down. Now, whenever it goes up, the way we control the speed of that is to the right of that regulator, you see a needle valve right on top of that check valve. If you screw that needle valve in, it restricts the flow escaping from that cylinder as the clamp moves up. All right, so if properly adjusted, those shock absorbers are barely doing any work at all. You can hear the air escaping at the end of that clamp's travel. That'll prolong the life of your shock absorbers, the bearings, the hardware on the end of the ski, your print head, if you have one on this clamp. Dampening all these clamps will do so much good for you, and you'll notice a difference just hearing the saw cut. It's one of the first things I do whenever I visit a new plant. The side clamp, it's got needle valves as well. You can see one here and one just to the back of it. The regulator for it, we'll put up a video here in a second, is down in front of the saw. You set that one to 30 PSI, and it's the same process. I'd have somebody at the screen clamping and unclamping it for me while I play with these 2 needle valves to get it to get to where it needs to be without slamming as hard as it can. You want to protect these bearings and, most importantly, that printer that's on this side clamp. If you have a rear printer, you have these ink lines. It says inspect air lines and ink lines for damage. Just make sure they're not kinked up somewhere where it's going to get trapped by this clamp. Inspect electrical connections for tightness. We have this solenoid up top. I've never seen one come loose, but it doesn't hurt to check and verify it's tight. This print cable, you can, every once in a while, undo this cable. Probably find it's full of sawdust, blow it out, plug it back in. Just save yourself some intermittent print issues down the line. Inspect side clamp air cylinder sensors for tightness and damage. Just like the top clamp, this sensor has, or this cylinder has 2 sensors attached to the cylinder. So verify that they're not sliding around anywhere. The most important thing, other than dampening this clamp, is keeping this area clean. So the sawdust and ink spraying all over it, it gets like concrete. This little box in here just holds all this sawdust and crud and stuff in here. I like to take this entire guard off and pull all that junk out of there. We don't want to put compressed air in there because we don't want compressed air anywhere near our print heads. Those tiny little needle valves are very, 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 not needle valves, spring valves. They're very sensitive. We don't want to ruin a printer trying to clean. But I like to pull all the junk out from under the side clamp assembly. Just verify that it can move freely. On the back of the Infeed rail, we have the pull cord for the gripper. It's just an e-stop. Make sure that this yellow cable at the bottom is tight. You can see this sight window with that little green arrow. You want to adjust the tension of this cable on the right, this turnbuckle, to get that dead center. It's kind of a tricky one because if it's just barely off, it could trip an e-stop and be hard to troubleshoot intermittent. On to the next one, we're going to be at the very end of the infeed rail to the gripper. All right, so at the end of the infeed rail, we open this door up and we can find our gripper assembly. Always verify that this home sensor cable is tight. Make sure all these sensors and air lines, none of them are breaking or hanging in a weird spot where you might think they'll get snagged. This E-chain has a tendency to come apart right here. Verify that it's put together. If it comes apart, you'll damage the cable and you have to run it all the way back to your saw. It's not fun. Down here, we were talking about the aluminum pulleys. These wear smooth as well, and it'll let that belt skip teeth more than it should, and your parts will come out incorrect. So if you take one look with a flashlight and you see it's silver, you see it smoothed out, it might be time to replace it. The new ones are made of steel or black. I've never seen one fail either. So if you take a flashlight and you see the pulley is black, you should be fine. These two linear bearings on the gripper, the easiest ones to check on the saw. I like to grab this silver air cylinder right here, just shake it up and down. If it's got any play at all in it, you know those bearings are probably bad. All right, a lot of you guys recognize this orange piece up here at the very front, the little flipper deal with the magnet in it. We call it the target sensor. That thing takes a lot of abuse too, smacking into the end of boards. Always keep one or two of them on hand, because if they break, you're down. You can re-weld them, but I've never seen one re-welded last more than a month. So it's always something you want to keep on the shelf. These little pads too, where these, let me go back here. These pads with these little grooves on them, you want to keep a set of those on the shelf as well. Opposite of that door that we had open, we have the gripper gearbox, the servo motor. So at the end of this servo motor, a little green cable, I had one come unplugged on me one day, and it took me about 15 minutes to figure out what the issue is. It's just a little twist lock go on there. I've only had one come off, but make sure it's on there tight, as well as that orange one. Between the servo motor and the gearbox, there's a Lovejoy coupler. Torque on it's 89 inch-pounds. Not very heavy, but over time, if it loosens up, imagine that gripper coming in to grab a 2x12. It's a lot of force grabbing a wet 2x12. That coupler can slip. Your parts could be off a foot or more. So if you call into customer service, your parts are off a foot or more, it's usually where we'll point you. It's a pretty handy page on our website showing you exactly what to check for gripper slippage. There's another coupler on the output side of that gearbox. I don't think I've ever seen one slip. It's a lot beefier than that small one. On our website, mitek-us.com, you can find a lot of troubleshooting information about the blade saw. And the 1-800 number, our help desk, we actually direct you here for a few things. Most notably, for gripper and nozzle slippage, my favorite, gripper slippage error graphic. Give you a step-by-step of things to check on here. See right here, this is that coupler I was talking about, the 89 inch-pounds. Then that bigger coupler, 309 inch-pounds. I really don't memorize these numbers. I always come back here and double check it because I don't trust myself. But give you step-by-step. Number one is the most likely thing to be wrong. Then check number two, number three. There's so many things on this website that are underutilized. Stroke slippage. It's pretty much the same steps, but a different axis. It's got pictures. Just fantastic resource for troubleshooting. So in the saw chamber, one thing I like to do, I like to grab the blade and spin it and see if I can see it wobbling or anything. If it's wobbling really bad, you should be able to hear it while you're cutting. I hope you would. And if you do hear it making a noise, stop cutting until it's figured out. Something else with the saw head, I like to grab the back of the motor and the front of the saw blade, see if I can find any slop in it rotating left or right.
It's really, really bad to have any slop in this. So the way we check it, we try and rotate the blade this way to see if it has any play at all, which it doesn't. This one does not. If it did, you would feel about 1/4 of an inch left or right slop.
Between the gearbox on top of the saw head and the black motor on the back, these are for the bevel, which is rotating this way. There's a small Lovejoy coupler, 2 pieces of metal with a rubber bushing between them. That rubber bushing, if it wears out, it goes away. Now you've got mechanical slop where it's kick, 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 kick. It's usually about 1/4 to 1/2 inch you can feel moving left to right. It's very bad. Your saw blade won't be cutting true into the board. Could cause more damage to the saw motor bearing, the shaft, the hub, things we do not want to damage. And bevel, if your bevel's off and you try to calibrate the rest of the machine, all of your other calibrations will be off. Bevel is super important. I don't like to mess with it at all. Take every precaution I can. Looking down at the lozenge, that silver jaw directly in front of the saw blade, the jaw closest to us, we call that the fixed jaw. The other jaw is the one that actually moves whenever it clamps. That fixed jaw, it'll have 2 grooves in it running along it, just wear marks. If your lozenge is completely smooth, it's probably time to replace that jaw, because that jaw is what we align the entire infeed rail to whenever we install it. And the Outfeed clamp is in line with it as well. If you have bad bearings, I've had it a few times where I could grab that lozenge jaw and I could feel it rocking back and forth, just like we were grabbing the gripper and moving it up and down. But there's a easier way to check for bad lozenge bearings. Over here on the very left side of the screen, you see that this blue donut encoder. Rarely, but it has happened. That cable plugged into the bottom of it has come loose. Just verify that's tight. Your saw is probably a lot dirtier than this one we're looking at. A lot of ink and sawdust built up in this area. I like to keep it blown out, because if you have to replace the cable, it's not fun to dig it out of ink and concrete at the same time. These ink bottles down at the bottom, I like to check for air leaks. The regulator to the right of the bottles, the sticker says 12 psi max. If you have all the bells and whistles on this saw, 2 32 valve print heads and a 7 valve edge, you can run 12 psi. If you've got one 16 valve printer in the front, you don't need 12 psi to run the whole thing. So you can be a lot easier on your printers, run like 7 or 8. As long as ink's coming out and it's legible, you have enough air pressure. You can barely see it, but there's another electrical chain, or E-chain we call it. It says, check E-chain and lozenge belt for damage or wear. Clean any debris from the belts. That E-chain, I've seen a couple of them break. I've been at a saw where they just took it off completely. The sensors that run through that chain, they're not fun to replace either. Make sure the E-chain's in good shape. This lozenge belt's just like the stroke belt. I go a foot off of the pulley, check 1/4 inch up and down. If you want to check the check to see if your rosin bearings are bad. A good tell is looking at the ends of the bearings, the dust cap, the green red portion of it. If you see that it's flared out or broken up, I will almost guarantee that bearing is bad. So if you take that bearing out of that assembly and slide it over, you should feel it flopping around. Bad bearing. Bad bearings will give you inconsistent parts. It's no bueno. All right, now on the drive end of the LOSM, all the way to the right, we have our LOSM motor, LOSM gearbox. It's not really too much to check over here. I always verify the home sensor's tight, the cable going to it. Blow out this whole area because there's a lot of cables running through there, and if you need to replace one, it's easier on a clean saw. Moving on to the skewed conveyor, number 4. All right, this is the picture we took looking from the very end of the skewed conveyor towards the saw. You can see these V wheels. I think they call them sheaves. They just by nature of this skewed conveyor, all the rollers up top, they're skewed, obviously. So they push this belt one way into one edge of the pulley. So one edge will always wear out faster than the other. It seems like about 4 or 5 years or so, it'll wear down enough to where it can skip off of that pulley, and now your belt's burning up. Instead of replacing them all, you can get away with taking those pulleys off, flipping them 180 degrees and reinstalling them, get another 5 years out of them. It's good practice to get under here every once in a while and make sure there are no cables in the way of the belt. Make sure the belt tension's correct so it's not slapping into a cable, because you have a couple E-stop cables running through here. If you mess up that cable, you're down all day. All right, number 5, the electrical cabinet. Oh no, we're going to talk about the outfeed clamp, my favorite. So this outfeed chain down here on the right should have 3 rows of teeth on it. I've seen manufacturer defects where they only have the outer 2 rows. No matter how much you adjust this clamp, you're going to have problems ejecting parts. So go check out your outfeed chain, make sure it's got that center row of teeth on it as well, to make sure you're giving yourself the best shot. Tension on this chain, people kind of vary on how they like it. Some people like 1/4 of an inch. I like to grab it in the center and pull it out just under 1 full inch. That's the tension that I set it to. On the back here, you can see 4 more linear bearings and another air cylinder. Now, with all of these clamps, they have needle valves to help dampen these clamps at the end of their movement. So if you go out to your saw right now and you have the operator clamp and unclamp, I'll almost promise that outfeed clamp's going boom, boom, boom. I think we have a video we can lay out in front of it.
I think that's enough to get the idea. Oh my gosh. Someone's got these well beyond finger tight. And then now, I think it looks good. Let me
We're over this. These needle valves will help prolong the life of so many parts on these clamps. The top clamp, side clamp, outfeed clamp. They're so easy to adjust. Verify your clamp pressure, and you have somebody running the clamp button while you mess with these needle valves. Just dampen the end of it so the end of the clamps travel, so it's not full bore metal on metal slamming into stuff. be surprised how much better your saw will run, how much longer it'll run. So if you guys have any questions at all about your blade saw or any other equipment, really, please feel free to call the 1-800 number. It's 1-800-523-3380. I actually call it probably once or twice a week, believe it or not, when I'm on the road. But we have a lot of technicians that spend a lot of time on the blade saw, some even better than me. Well, I want to thank you guys for paying attention to me for this whole presentation. If you guys have any questions at all, feel free to reach out to us. The 1-800 number is your best bet. We got a lot of smart folks out there. That's 1-800-523-3380. Now, this inspection of the blade saw, you can do it however often you'd like. Perfect world, it'd be every day, but I don't think anyone's got enough time to do all that. The most important thing about this entire slideshow, you can print it off, laminate it. It's just putting eyes, ears, and hands on all of this stuff. It's about every saw that I go to that's had this problem for however long, if they even know it's a problem, they haven't been looking at it. But it takes a quick inspection. You can, the gripper example, been having bad, inconsistent parts for a week. It takes 1 second to grab that air cylinder, move it up and down on the gripper. Really just looking at it every day, you'll find things out of the norm a lot faster than looking at it only when it breaks. So if there's anything that you guys get from this, it's look at the saw every day, know what it's supposed to look like, and address it whenever you find something out of the norm. Thank you.